Okay, so we're doing the questions and answers on qualitative analysis. So let us take a look at the answers. So the first question was, which aqueous ion causes a yellow precipitate to form when acidified aqueous lead nitrate is added to it? Again, I'm going to remind you that lead nitrate is the same as the test for silver nitrate. So silver nitrate was a test for what? Silver nitrate or lead nitrate are tests for chloride, bromide, iodide. Now, which one gives a yellow precipitate? Remember that the only thing that gives a yellow precipitate in all our tests is iodide. Okay, so this is a test for iodide. When sodium is burnt in oxygen, what color is the flame? So what was the flame test for sodium? The flame test for sodium was yellow. Okay, a mixture containing 2 anions was tested and the results are shown below. Dilute nitric acid was added. He got effervescence of a gas which turned lime water milky. Remember that if I add any acid, whether it's dilute hydrochloric or dilute nitric, an acid on something, and I get effervescence of a gas that turns lime water milky, that means I have carbonate. That is the test for carbonate. Now, the other test was dilute nitric acid added, followed by aqueous silver nitrate. Again, silver nitrate is the test for what? Chloride, bromide, iodide. Now, which one gives a yellow precipitate? We just mentioned that the only one that gives a yellow precipitate is the iodide. So that means that I have carbonate and iodide. Okay, compound X is tested and the results are shown. Add aqueous sodium hydroxide. And then heat gently. The gas given off turns damp red litmus paper to blue. This is a test for what? That's the first thing you ask yourself. Sodium hydroxide warm gently and it gives off a gas that turns damp red litmus paper to blue. You should remember that this is test for ammonium ions. And then he adds dilute hydrochloric acid and he gets effervescence, gas given off. Again, we said if I add acid and I get a gas that turns lime water milky, that is the test for carbonates. So the X is a compound made of ammonium ions and carbonate ions. Do you understand the idea? Okay. The results of 3 tests are shown. He put aqueous sodium hydroxide and he got white precipitate soluble in excess. He added aqueous ammonia and he got the same thing, white precipitate soluble in excess. Now, which one did we say gives white precipitate soluble in excess with both sodium hydroxide and aqueous ammonia? That was the test for zinc. Okay, dilute hydrochloric acid added and he got bubbles of gas, and we said if I add acid and I get bubbles of gas, that is the test for carbonate. So this is zinc carbonate. Okay, here he says some barium iodide is dissolved in water. Aqueous lead nitrate is added to the solution until no more precipitate forms. Again, lead nitrate or silver nitrate was test for what? This was test for chloride, bromide, iodide. Now, which one do I have? I have iodide, and we said the iodide gives a yellow precipitate. So X is yellow. So my answer is either C or D. Then he says he added dilute sulfuric acid to the filtrate. Now, what is in the filtrate? What is in the filtrate is barium. Actually, it's barium nitrate, so it's a barium nitrate solution. Now, I'm adding it to sulfuric acid. If you remember, barium nitrate was test for what? Test for sulfate. Now, does sulfuric acid have sulfate? Yes. And it's supposed to give what kind of precipitate? If I have barium nitrate with something that has sulfate, I should get a white precipitate. So that means that Y is a white precipitate. You should understand how to deduce the answers, okay? So 2 tests are carried out. I have test 1. He added, actually he has copper sulfate and sodium chloride. That's what he has in his solution. And he's adding in test 1, he's adding barium chloride. So I need to ask myself, barium chloride is test for what? It's test for sulfate. Now, do I have sulfate? Yes. If I have sulfate, what am I supposed to get? The test for sulfate was add barium chloride or barium nitrate. And if I have sulfate, I should get white, not blue. So that first test is wrong. Now, the second test says he's adding silver nitrate. And remember again, Silver nitrate is test for what? Chloride, bromide, iodide. Now, which one do I have? If you look up there, I have chloride. So, what am I supposed to get with the chloride? I'm supposed to get a white precipitate, so that test is correct. So, test 1 is wrong, but test 2 is correct. Do we understand that? Okay. A solution contains barium ions and silver ions. And actually, the key word in this statement is the word solution. So I have barium something and silver something that are soluble. So they form solutions. And the question is, which of these alternatives that I have will form a soluble solution? So if I have barium something and silver something and I want them to be soluble, remember that we said all what are soluble? All nitrates are soluble. So barium nitrate, silver nitrate, so the anion must be a nitrate. Okay? Aqueous solution S is added to aqueous ammonium chloride. The mixture is heated and I got ammonia. So what do I add to ammonium to get ammonia? Remember that. What we use to test for aqueous ammonia, our ammonium ion, is a base like sodium hydroxide. Okay? Which two compounds give a white precipitate when their aqueous solutions are mixed? Looking there, silver nitrate and sodium chloride immediately come up as a correct answer. Okay, aqueous sodium hydroxide is added to solid X and the mixture is heated. He got a green precipitate and an alkaline gas. Now, first of all, if I add sodium hydroxide to something and I get a green precipitate, that means that I have what? It means that I have iron 2. So I have iron 2 plus. And then, what was the tests in which I add sodium hydroxide and the mixture is heated and I get an alkaline gas? That was test for ammonium. So now I have ammonium and iron 2 plus. Okay, then he says aqueous sodium hydroxide and aqueous ammonia each give a white precipitate when added to zinc sulfate. So this is a test for zinc. Now what was the test for zinc? We said in both cases, if I add sodium hydroxide or if I add aqueous ammonia, I get a white precipitate that is what? That is soluble in water, in both cases. So in both cases, if I add excess of the reagents, I will have the precipitate dissolving. Okay? Okay, a mixture produces a gas both when it reacts with acid and when it reacts with alkali. Which ions are present? Okay. Now, which test we said I add acid and it gives bubbles of gas? That was test for carbonate. And which test did I say I add sodium hydroxide, for example, or an alkali and I get a gas? That was test for ammonium. So that means that I have ammonium ions and carbonate ions. You have to memorize the tests. It's very essential, very important. Okay, state a chemical test for water. Remember we had a chemical test and a physical test. Here he's asking for a chemical test. Which one was the chemical test for water? Add anhydrous copper sulfate. You have to mention the word anhydrous. Add anhydrous copper sulfate. It turns from white to blue. Describe the test for hydrogen. What was the test for hydrogen? Insert a lighted splint. It pops. Okay. What was the test for alkenes? For alkenes, add bromine water. It turns from reddish brown to colorless, or we said you could say orange to colorless. Without using an indicator, describe how you could show that a compound is an acid. Remember that if I have an acid and I want to show it's an acid, I could simply put in litmus paper or universal indicator, but he doesn't want that. He doesn't want using an indicator. So we think, okay, we use acid to test for what? Remember that we use acid to test for carbonate. So in that case, I could also use carbonates to test for acid. So if I add, for example, a specific carbonate like sodium carbonate, and I want to show that this is an acid, if I add sodium carbonate, I should get bubbles of gas that turn lime water, milky, right? Describe how you could show that the reaction mixture contained an iodide ion. Okay, what was test for iodide? Add dilute nitric acid and silver nitrate. And remember, you need to add both. You don't just add dilute nitric acid and that's it, because actually what gives the precipitate is the silver nitrate. So I'm just adding the nitric acid to make it an acidified solution. So you need to include dilute nitric acid and aqueous silver nitrate. What do you get with iodide? You get yellow precipitate. Our yellow precipitate is formed. Okay, I have two fertilizers, something that has ammonium and something that has calcium. And he's saying describe a test to distinguish between these two fertilizers. Okay, when we are asked to distinguish between two things, what we're required to do is we give one test that will either work with one but not the other, or give different results with both. So, for example, I want to distinguish between ammonium and calcium ions. So I can add what? I can add aqueous sodium hydroxide to each solution. Now, with the ammonium, I mentioned what I should get, and with the calcium, I mentioned what I should get. So with ammonium ions, the ammonium ions will give bubbles of gas on warming that turn damp red litmus paper to blue, while the calcium ions, if I add sodium hydroxide, they give what? White precipitate insoluble in excess. Okay? Describe how you could test the solution to find out which ion, ion 2 or ion 3, is present. Again, ion 2 or ion 3. What is the test that I could use to distinguish between them? Add aqueous sodium hydroxide. And then you tell me, with each of them, what should I get? With ion 2 plus, I get green precipitate. Ion 3 plus gives reddish brown precipitate. Okay, here he's asking for a physical test for pure water. What was the physical test for pure water? Heat to boiling. It boils at 100 degrees centigrade. Give a chemical test for the presence of sodium hydroxide. What was the test for sodium? We didn't do a test for sodium hydroxide, but we use sodium hydroxide to test for something. So I can use that something to test for sodium hydroxide. So what did we use sodium hydroxide to test with? For example, I used it to test for copper. So here I can add copper something, like copper sulfate, for example. Then, if that solution is sodium hydroxide, I will end up with a blue precipitate formed. Do we understand this? Okay. Give a chemical test. Actually, for the sodium hydroxide, you can use any of the things that we use the sodium hydroxide for. For example, you could say add ion 2 sulfate, ion 3 sulfate, ion 2 chloride, ion 3 chloride. It's preferable to use something that gives a color that is visible. I wouldn't say, for example, add calcium chloride, because calcium chloride would just give me a white precipitate, and many things give white precipitate. But blue, for example, with copper is something that is a bit unique. So you use copper something, or ion 2 something, or ion 3 something. Okay, give a chemical test for chlorine. What was the test for chlorine? The test that we have is insert damp blue litmus paper. It bleaches. Okay? Now, here he has 3 bottles, pentene, sodium iodide, and ammonia, and we want to do tests to distinguish between them. Okay, so what is the test for pentene? Remember that anything that ends with "ene" is an alkene, and we have tests for alkene. What was our test for alkene? Add bromine water, it turns from reddish brown to colorless. Okay, what is the test for iodide? Here I have something iodide, so I want to test for iodide. What was the test for iodide? Dilute nitric acid and aqueous silver nitrate. I end up with a yellow precipitate. Aqueous ammonia. Again, what was the test for aqueous ammonia or ammonia solution or ammonium? All of them are the same. Aqueous ammonia, ammonium, ammonia solution. We add aqueous sodium hydroxide, warm gently. What should I get? Bubbles of gas that turn damp red litmus paper to blue. Okay, this is another test where I have 3 bottles and I'm trying to test for them. So the first one is chloride. What was the test for chloride? Again, dilute nitric acid and aqueous silver nitrate. With chloride, I should get white precipitate. What was the test for ethanol? Okay, we said the test for ethanol, because ethanol is flammable, I put a lighted splint near the liquid catches fire. Do you understand this? Okay, again, test for sodium hydroxide solution. We said we use something that we react with sodium hydroxide, so something like aqueous copper sulfate or iron 2 chloride or sulfate or iron 3 something. Okay, if I use copper something with sodium hydroxide, it should give a blue precipitate. Okay, this is another question. A student investigated the reaction of methane and copper oxide. She passed methane gas over hot copper oxide using the apparatus. The solid changed color to red-brown and drops of liquid condensed in the cold part of the tube. What was the original color of the solid? What did he have in the in that test tube? He said he had copper oxide. What was the color of copper oxide? You should know. The color of copper oxide is black. It's a black solid. Now, he's saying that this black solid is going to change to reddish brown. What do you think the copper oxide will change to? It will change to copper, and the copper is a reddish brown solid. Now, what do you think is the liquid that is formed? What am I doing? I'm doing copper oxide plus CH4. So, what do you think the drops of liquid are? The drops of liquid are water. So just a physical test to identify that this is water. What was the physical test for water? Heat to boiling. It boils at 100 degrees centigrade. Okay. This is another type of questions that you get in paper 6. A mixture of two solids, G and H, was analyzed. G was water soluble and H was copper carbonate. So, and G is water soluble and he doesn't tell me anything about it. H was copper carbonate, so H is the residue. Okay. The mixture was added to water in a boiling tube. The mixture was shaken. What is the test on the filtrate? So the filtrate is the water soluble one, so the filtrate is G, right? Okay, to the filtrate, dilute nitric acid was added, followed by silver nitrate. Again, what is the test? What is silver nitrate a test for? It's test for chloride, bromide, iodide. So if I get white precipitate, that means I have what? That means I have chloride. Okay? Then to the filtrate, dilute sulfuric acid was added and I got white precipitate. So I'm adding dilute sulfuric acid to what? To G, and I got a white precipitate. So that means, what gives a white precipitate with something that has sulfate? Well, what was the test for sulfate? The test for sulfate was barium nitrate or barium chloride. So if I put barium nitrate or barium chloride, barium something, on sulfate, I get a white precipitate. So here I added sulfuric acid that has sulfate to something and I got a white precipitate. That means that something must be barium 2+. Okay, test on the residue. Now the residue, I'm going back again and seeing the residue was copper carbonate, right? Yes, the residue was copper carbonate. Okay, good. So a little of the residue was put into a test tube and dilute nitric acid was added. So if I add dilute nitric acid to something carbonate, so this is acid to carbonate, I should get bubbles of gas that turn lime water milky. And the contents of the test tube were kept for test D. Test D says the contents of the test tube, okay, to the first portion, so remember that we still have copper carbonate. So the first portion, an excess of sodium hydroxide was added. If I add sodium hydroxide, something that has copper, blue precipitate. To the second portion, a few drops of aqueous ammonia, drops. Remember, when I add drops to copper 2+, I get blue precipitate at the beginning, but then with excess, the precipitate dissolves to form dark blue solution. So what conclusions can we draw about the solid G? Solid G, that was the first one. That was the one we found was barium chloride. Okay. Another question, two salt solutions J and K were analyzed, and he's telling me that J is iron 2 sulfate. Okay, so tests on J. Appearance of solution J. If solution of J is iron 2 sulfate, remember iron 2 compounds have what color? Iron 2 compounds are green, so they are the same color as the precipitate that we get when we test with sodium hydroxide. To about 1 centimeter cubed of solution J, which has iron 2 sulfate, I added sodium hydroxide. What happens if I add sodium hydroxide to iron 2? Green precipitate. That's why you have 2 marks. Okay? Precipitate is 1 mark and green is the other. To about 1 centimeter cubed of solution J, an equal volume of aqueous ammonia was added. If I add aqueous ammonia to something that has iron 2, green precipitate. To about 1 centimeter cubed of J, dilute nitric acid and silver nitrate. Now, again, silver nitrate is test for what? It's test for chloride, bromide, iodide. Now, do I have any of this? I have iron 2 sulfate. I don't have chloride, bromide, or iodide. So if I add silver nitrate, no change or no reaction. Now, to J, I'm adding dilute nitric acid and barium nitrate. Now, barium nitrate is test for what? Test for sulfate. So if I add the barium nitrate to iron 2 sulfate, I do have sulfate. What should I get? I should get a white precipitate. Okay. K, we don't know anything about K, but he's saying that the appearance of K is a dark pink liquid. Now, if we say that something is colored, that means it has a transition metal. So the fact that it is dark pink liquid, it means it's transition metal. But we don't really know which transition metal because it is pink. We didn't talk about anything that's pink. So to about 1 centimeter cubed of solution K, he added sodium hydroxide and he got a blue precipitate. This is really confusing because if I get blue precipitate, we did this as a test for copper, but actually if I have copper in my solution, my original solution should be blue, not pink. So this means, this test G just means that I have a transition metal. I'm not going to say it's copper because if it were copper, then the appearance of solution K should have been blue. Do you understand the idea? It's a bit confusing because we said sodium hydroxide should give blue precipitate if I have copper, but then I should know that all copper solutions are either blue or green, not pink. So that means this is not copper. It's some other transition metal. Okay. To solution K, aqueous sodium hydroxide and aluminium powder were added. And the mixture was heated, effervescence, pungent gas evolved, damp red litmus turned to blue. This is test for what? Sodium hydroxide, aluminium powder, heat, and it gives out gas that turns damp red litmus paper to blue. You should remember that this is test for nitrate. So, first thing, identify the gas given off in test H. Yes, test H. Which gas turns damp red litmus paper to blue? Ammonia. So, from these tests, what conclusions can you draw about solution K? We said it contains a transition metal, but I cannot say copper because the solution is pink. Okay, so it is some other transition metal. And test H, of course, was the one that told us that we have nitrate ions. Okay, another test. Two different liquids, A and B, were analyzed. A was an aqueous solution of ethanoic acid. So A is ethanoic acid. B is some liquid. Okay? So liquid A was divided into 3 equal portions. Color and smell of liquid A. What is the color and smell of ethanoic acid? We said, first of all, that ethanoic acid is the same as vinegar, so it is a colorless solution with smell of vinegar. Now, the liquid was added to the universal indicator. Ethanoic acid was what? Was it a strong acid or a weak acid? You should remember that ethanoic acid, which is actually vinegar, is a weak acid, and a weak acid should have pH what? It should have a pH of 4, 5, 6, and the color should change from green to orange or yellow, right? and we can put a certain pH, either 4 or 5 or 6. Okay, then in the next test he says a piece of magnesium ribbon was added to the second portion of ethanoic acid. So I'm adding magnesium, which is a metal, to acid. Metal to acid, I should see bubbles of gas. Lighted splint pops because the gas that comes out is hydrogen. Okay, calcium carbonate was added to the third portion of the liquid, which is an acid. So I'm adding calcium carbonate to an acid. I get bubbles of gas. And if he asks what is the gas is carbon dioxide. Okay, tests on liquid B, which he didn't tell me anything about. He did dilute sulfuric acid was added, followed by aqueous potassium manganate. The mixture was heated. It changed color from purple to colors. Now I'm going to tell you that potassium manganate is an oxidizing agent. We haven't done that yet, but potassium manganate is an oxidizing agent, and anything that works with it is a reducing agent. So if something reacts with potassium manganate and changes its color from purple to colorless, then I just say that B is a reducing agent. Liquid B was poured onto a dry watch glass. The surface of the liquid was touched with a lighted splint. The liquid burned. So this was test for something that is flammable, and anything that's flammable is usually an organic compound. So if I bring a lighted splint and the liquid burns, that means I have an organic liquid. So it is a reducing agent because it reacted with potassium manganate, and it is an organic flammable liquid. Okay, two different liquids, H and J, were analyzed. H was an aqueous solution of copper 2 sulfate. So what I have is copper 2 sulfate in H. So what is the appearance of H? What was the color of copper sulfate? You should know the color of copper sulfate. It's blue. Appearance and smell of liquid J. What does he tell me about J? Oh, he's given me the distinctive smell. Okay, and then he's saying distilled water was added, and I have 2 layers of liquid visible. Now, if I add something to water and it forms 2 layers, that tells me that that something is an organic compound that is not miscible with water, something that doesn't dissolve in water. So it formed 2 layers of liquid. Okay, to liquid H, what does he say about H again? That it is copper sulfate. Was added dilute hydrochloric acid and barium chloride. Again, barium chloride is test for what? It's test for sulfate. Do I have sulfate? Yes. So I should get white precipitate. To a little of liquid H, excess sodium hydroxide was added. So I'm adding sodium hydroxide to what? To copper 2. Well, that is what gives blue precipitate. To a little of liquid H, I added aqueous ammonia. Again, if I add aqueous ammonia to copper 2, what should I get? Blue precipitate. And then if you add excess ammonia, the precipitate dissolves to form dark blue solution. You have to memorize the tests. A few drops of liquid J were put on a dry watch glass. The liquid was touched with a lighted splint. The liquid burns. Again, if he just says that he put a lighted splint and the liquid burns, that means it is an organic flammable liquid. So what do we know about J? That it is organic flammable compound. Okay? 3 different liquids, P, Q, and R, when analyzed. P was an aqueous solution of sulfuric acid. The tests on the liquids and some of the observations are in the following table. So he's telling me that P is sulfuric acid. So what is the appearance of P? If you should know that all acids are colorless. So this is a colorless with no smell. Okay? Now he has something called Q that he says is colorless with smell of vinegar. Which one did we say has a smell of vinegar? That must be ethanoic acid. Okay. What is the pH of P? He says P is sulfuric acid. What is the pH of sulfuric acid? pH of sulfuric acid can be 1 or 2 or 3. Okay? And he says Q has a pH of 5, so that is correct. It must be ethanoic acid because ethanoic acid is a weak acid. Now R is something that is colorless with no smell, and it has a pH of 7, so that is something that is neutral. Okay, A piece of magnesium ribbon was added to a little of each liquid. Now he's adding magnesium to what? P is sulfuric acid, so he's adding P to acid, magnesium to acid, sorry. If you add magnesium to acid, we get rapid effervescence. Because Q, he wrote Q gives slow effervescence. Q is a weak acid, it will give slow effervescence. So P is a strong acid, so it should give a rapid effervescence. And R, there is no reaction, so R, because R is neutral anyway, it's not an acid. Okay, and he's saying the gas given off by liquid P was tested, so the lighted splint pops. Remember that we have magnesium with acid, so it gives hydrogen gas. If I test it, it is with a lighted splint and it pops. Okay, to a little of liquid P, hydrochloric acid and aqueous barium chloride were added. Again, we're going to remember that P is sulfuric acid. So if I add barium chloride is test for sulfate. Sulfate will give white precipitate. Now, liquid R was heated to boiling in a test tube, and he found that it boiled at 100. What is the liquid that boils at 100? Water, right? So what conclusions can we draw about liquid Q? So what did we find about liquid Q? That it's a weak acid and it has a smell of vinegar, so that means it is ethanoic acid. Identify liquid R. We said liquid R is something that boils at 100 and it is neutral, so that is water. Okay, a mixture of two solids C and D were analyzed. Solid C was lead nitrate, which is water soluble. So that is, once he tells me that it is water soluble, then that is the filtrate. So the filtrate, which is C, is lead nitrate. Now, to about 1 centimeter cubed of the solution, a few drops of dilute nitric acid and aqueous potassium iodide was added. What was C again? C was lead nitrate, and lead nitrate is used to test for chloride, bromide, iodide. So if I put lead nitrate on iodide, we said that is the one that will give yellow precipitate. To about 1 centimeter cubed of the solution, sodium hydroxide and aluminium powder were added. Now ask yourself, this is test for what? Sodium hydroxide with aluminium powder, that is test for nitrate, and I do have nitrate. So what am I supposed to get? Pungent smell, because a gas comes out, which is ammonia. Bubbles of gas that turn damp pH paper or damp litmus paper blue. He says pH indicator paper. It's the same as litmus paper or universal indicator paper. Okay, tests on the residue. This is something we don't know about, so he's going to give me information. Dilute hydrochloric acid was added to the residue. The gas given off was tested with lime water. So if I add acid to something and it gives rapid effervescence, lime water turns milky, that means I have carbonate, and the gas given off is carbon dioxide. Okay, the solution was divided into two equal portions. To the first portion, I have sodium hydroxide. It gives white precipitate soluble in excess, aqueous sodium hydroxide. To the second portion, I added aqueous ammonia. It gave white precipitate soluble in excess. Now, which one gives white precipitate soluble in excess with both? Zinc. So that means that I have zinc carbonate. Okay. Okay, so that's the end of it. And you're supposed to study all of this and get ready for the quiz and let me know. Okay.